Hello everybody and welcome back to my channel Jela Bamba. This is Jamila Orior. I am back with another installment of the fifth chapter of the science and culture behind psychotropic drugs. Um, this chapter is quite long and very informative actually. So the chapter starts with a quote from the 19th century novel that sings the praises of laudanum. And the Victorian physician described morphine as God's own medicine. Opium has been used for both therapeutic and recreational purposes for a long time ago. The author reveals how he bought a collection of poems by Edmund Spenser while in London, found a letter within the folds of the book addressed to William Wilkie Collins. The letter was written in 1869 by Christina Rossetti, a romantic poet. The author of the letter talked about how laudanum ruined her brother's life, Dante Gabriel Rossetti, and his wife Lizzie, who was addicted to laudanum and died on an overdose. She advised Mr. Collins to be aware of the dangers of laudanum, as she had suspected he might had also been a user. She included her Homeric poetic allegory, The Goblin's Market, in the letter, where she describes how, that seductive dance with the addictive substance and trying to run away from it and getting back to it until it ends you, kind of. Now, opium and the ancient is the next section. Opium is the most ancient psychotropic and mind-altering substance, most effective for analgesia. Its major psychoactive ingredients are codeine and morphine. It has also always held a valuable place in the therapeutics and has also been a major source of income to many countries. Opium poppy cultivation is also ancient. Evidence found in Neolithic tombs in Switzerland, Central and Southern Europe, up to 4000 BC. How were poppies used? Morphine is found in a small amount in all poppies, but only opium poppy, or what scientifically known as Papaver somniferum, carries pharmacologically significant levels. Papaver somniferum has certain parts of the plants that are concentrated in opium, but not the seed. Therefore, ancient relics of poppy seeds do not necessarily mean they were used in the ways we know. Seeds can be used to make oils or other preparations. It is, however, believed that ancient Sumer cultivated the poppies. Drawings of opium poppies found in Mesopotamian bas relief, those slightly raised sculpture on a flat surface that gives that kind of a 3D-like picture. Well, the Assyrian tablet dating also back to 1700 BC interpreted as containing names of drugs in Sumerian. Some of the drugs were reported to have existed 3000 BC. The opium poppy was among these drugs that were mentioned in the Sumerian transcript that dated back to 3000 BC. Ancient ideogram tablets from the 3rd millennium BC referred to the plant as the joy plant, as has been translated, but you gotta be careful because there is another translation that described differently, that translated what was said about the opium in different way. The same transcription, as I said, was translated differently by other anthropologists or archaeologists. Ancient Egypt also might have used the plant. In brief, the ancient knew a thing or two about poppies, including the opium poppy. Greek and Roman medical practitioners used the plant. Nepenthe, mentioned in Homer's Odyssey, that was in 800 BC, and described this thing this concoction that was called Nepenthe is described as a drug that chased the sorrow away, and they say it could have been opium. Materia Medica 70 AD by the Greek physician Dioscorides described many of the uses of opium. He also described how to prepare syrup and tablets for pain, cough, and diarrhea. Poppy capsules are boiled in water. The extract is boiled again with honey to make a syrup. It could also be cooled to make tablets to suck on for pain relief, cough or diarrhea, or a type of cough drops. Dioscorides is, in his Materia Medica, described the method for harvesting crude opium. The falling of the petals show the pea-sized seed pod of the poppy. Once the latter matures in a few weeks, it becomes ready for harvest. Tapping is the next step. The pods are sliced with a special knife that gets cleaned after each slashing. The exudate leaks of the seed pod, kind of a milky sap, is left to congeal overnight and scraped in the morning. The method is still current in certain areas, such as Afghanistan. It is molded in balls or squares and stored, retrieved for further processing before smoking or using it for the purposes. It is macerated in boiling water or evaporated to form concentrated paste. I'm going into these details from the books about how they used the opium, just to say that it has been used very anciently for therapeutic purpose. Modern pharmacology uses the dried pods and other parts of the poppy, what they called the poppy straw way, as described in the book. The Greek Galen, the father of the humoral theory, which he had derived from Hippocrates' works, thought that drugs such as opium could restore humoral balance. Therefore, it could restore health. Galen wrote that the Emperor Marcus Aurelius took Mithridatium or theriac, a cure, an all-cure remedy, herbal preparation included opium. Regularly, he was the emperor's physician. Now, the opium alchemy. The Galenic humoral theory lived for centuries. 16th century Swiss alchemist Paracelsus wrote almost about everything from magic to medicine. He had a new therapeutic approach. He introduced the use of specific drugs to specific disorders instead of seeking to balance humors. He extracted opium with alcohol to make a tincture. Other ingredients could be added. The tincture was called laudanum, and it survived for a long time. And it's derived from the word, the name is derived from the Latin laudere. It was to be used for a variety of disorders, therapeutic uses, not recreational. Now, if you have noticed, most of the uses, ancient uses, was for therapeutic purposes, and probably also for, and the book also argued in some other chapters for religious purposes. Now here the focus is on analgesia and therapeutics. It was to be used for a variety of disorders. Therapeutic use is not recreational. Dr. Thomas Sydenham, the English father of modern medicine, devised a laudanum recipe. And the laudanum recipe was 2 ounces of opium, 1 ounce of saffron, a dram of cinnamon, and cloves dissolved in 1 pint of canary, a type of Spanish wine. The concoction was for therapeutic use and became common prescriptions for a variety of disorders in Europe. Dr. John Jones, in his Mysteries of Opium, reveals in 1700 AD, discussed the side effects and benefits of opium with accuracy. He was also the first to tackle the issue of withdrawal. Now, it has started to become an issue, and this guy was the first one to talk about that. He was a user also. Dependency was not considered problematic back then, but rather therapeutic side effects. He highlighted the psychological dependency side effects and viewed it as a chronic and acute. It was not considered problematic, as I said back then. But when you talk about these issues, you kind of consider it has become a problem, be it just for a side effect problem. 18th century had known the first attempt to understand the mechanism of action of opium in a scientific methodic way. There was no standard preparation of laudanum or other opium preparations. New ways of the administering of the drug started to be investigated. Dr. Christopher Wren and Robert Ball initiated a primitive way of intravenous administration. They used the quill of a pen to inject opium in the vein of a dog, and the dog became stupefied. Similar experiments in Germany, the well-trained German Shepherd dogs fell in deep sleep when they were administered the opium using the quill of a pen to inject it in the vein. They didn't respond to commands, and they were German Shepherds are really very trained dogs, and they bellowed the commands in their ears. They couldn't wake them. 18th century had known the development of Brownian theory in reference to the Scottish physician John Brown, who developed it around 1780 and explained it in the Elements of Medicine. He believed that excitability, interactions with external stimuli, and the ability to respond to them, which he calls asthenia, and lack of it, which he named asthenia. Asthenia, you know how in Latin when you add that a before the word, it makes it as without or not. So there is asthenia, excitability, and lack of it, asthenia, are what affect health as disease results from asthenia. The disease resolves by restoring asthenia, restoring excitability. Being excitability like responding to stimuli. Brown suffered from gout and found relief in using opium. According to him, gout is a state of asthenia, and opium restores asthenia. He wrote that the opium was the strongest and most diffusible stimulant. Pharmacology research on the action of opium began in 1742 with Charles Alston, a professor of botany and materia medica at the University of Edinburgh. Experiments on frogs concluded the primary action of opium is on nerves, not by blood circulation. It was observed that the drug remained intact in the stomach despite the strong reaction. The drug must have had such reaction by affecting gastric nerves. When administered directly through the bloodstream, it affected nerves innervating the blood vessels. All this was challenged later. These findings were challenged later. The drug is absorbed first, then transported through the bloodstream to its site of action. Such idea was what heralded the modern understanding of the mechanism of drug action. 19th century, the mechanism of the action was understood. The active chemical principles contained in opium isolated, new opiates developed, and cultural movement was ignited. But this is more than just what happened with Prozac. This is a cultural movement that geared the whole generation, and we're still dragging its side effects or its effects up to the 20th century. Now, the identification of morphine. 19th century organic chemistry became a powerful field for scientific investigation for isolating compounds from natural products. Solvent extractions and crystallization were the methods used. After a few studies, they concluded that isolated active substances from natural products are acidic. Now they started experimenting on animals. Self-experimentation was excluded for toxicity risks. 1803, Charles Louis de Rosen crystallized a substance from opium he believed alkaline. So years later, a German pharmacist, Wilhelm Friedrich Sertner, isolated and crystallized a substance from opium that proved to be narcotic when tested on dogs. He named his substance morphium, after the god Morpheus from Ovid's Metamorphoses. He wrote a series of articles on the properties of morphium and how it readily reacted with acids to form crystallized salts. He self-experimented together with 3 students of his. They took 50 milligrams and got opium poisoning for a few days. If they got only opium poisoning, that means they were the luckiest people, because then there was no respiratory depression and probably coma or cardiac arrest. Anyway, a prominent French chemist, Joseph Gay-Lussac, read Sertner's article. He translated it and published it in a widely read French journal. Morphium became known as morphine and as an alkaloid chemical agent. Now they started to question the fact that all natural products derived from plants could be just acidic. Now they found out that morphine might be an alkaloid chemical agent. Opium as a plant has a large active molecules. Only 2 are narcotic, morphine and codeine, to a lesser degree. The latter was isolated by Pierre Robiquet in 1832. Thebaine was another alkaloid isolated from opium. It does not have narcotic effects. It is a stimulant instead of a narc agent, depressant, that can cause convulsion. So I said stimulants can cause convulsions, and it has been essential in the synthesis of other narc agents, very powerful narc agents. It is not active and narcotic, it doesn't have a narcotic effect, but can be used to create very strong ones, such as fentanyl. The actual chemical structure of opium was not actually clarified until 1923, and the complete synthesis of the substance was achieved in 1950. Delinquency and the rise of Romanticism. 18th and 19th century had known recreational use of opiate by artists as their psychological effects had become known. Romanticism, symbolism, and surrealism, and who haven't known that, have all been concerned with the subconscious and had their a work enveloped in an aura of dreaminess, and the author attributed that to the use of opium. Coleridge was prescribed opium for medicinal purposes and became addicted. The author thinks that opium must have affected his famous and appreciated uh, uh, rhyme, the rhyme of the ancient mariner. If you have read that poem, the author said, it might have been to a strong point affected by that, the imagery or something, because when you have those symptoms, it affects your imagination and the way you see the word. So De Quincey, Thomas Spencer De Quincey, is the first author to have turned opium into a subject matter. Now, it is not just talking about it's not only taking it and then writing, it's talking about it, making it your subject matter. He published articles in London magazine, which he collected and published as Confessions of an Opium Eater. Suspiria de Profundis, another work of his, for which he has opium as a theme, where opium is described as recreational, not medicinal. He describes how he initially used opium, gradually got addicted, his struggle between quitting and using. Now, here is one that knows the dangers of that substance. Similar to Rossetti, the one that wrote the poem. Artists' endeavors, although writers and other artists might have taken drug initially for medicinal use, they eventually took to it for its narcotic effect. The Club of Hashashin championed the use of cannabis and laudanum seeking artistic inspiration. Charles Baudelaire in France translated De Quincey's Confessions of an Opium Eater that has become sort of Bible to his clique. The Gothic movement was also influenced by opium. Laudanum remained in use in the 19th century, pure morphine as had been extracted by the German Sürtner. The Scottish physician Dr. Alexander Wood invented the hypodermic needle, providing therefore more direct administration of drugs. Laudanum use abated with the arrival of pure morphine and semi-synthetic derivatives. Opiates have contributed and continue to influence artists' work until today. Literature throughout the 20th and 21st century have been influenced by heroin. Opiates and the Industrial Revolution. Opiates have been disseminated in the society, and the common use of it had been freely available to all. You didn't need a prescription. There are no laws that illegalized it, and laws have been passed in England to contain the phenomenon of addiction. The laws did not cover meds that included opium, and there were so many. They say, it's illegal to take opium, but then there are medications for which you're entitled to take, and a lot of them contained opium. Medication that contained drugs varied from the ones for minor aches to headaches, diarrhea and vomiting, cholera, and all kinds of disorders. USA has been living very similar conditions that have worsened with the ignition of civil war. Soldiers' addiction to morphine has gotten its own name, soldier's disease. In brief, most meds contained opium. Opiates containing meds were easily accessible, and anybody can make a concoction and got a patent. Patents were really affordable and accessible. The Industrial Revolution had made the problem even worse. It had brought about suburban rural migration, and women joined the working force. Many had children. Children were cared for by the elderly. Parents wanted to come back to restful homes, to have restful sleep, to face another hard work day. Sleep syrup, narcotic concoctions were given to children to keep them quiet and send them to bed. Imagine what would happen to those kids, what had happened to them. Opiates have become endemic to all members of society from all walks of life. During those times, opium patented drugs were not used recreationally, but heroin was. Opiates have become such a cultural phenomenon that it's invaded all forms of art. Yves Saint Laurent, opium, and I love that perfume also, marketing campaign and sales was propelled by its name and Dante's Gabriel Rossetti painting of his wife who overdosed on the laudanum, and that's the brother of that lady that wrote that poem. Undoubtedly, Britain was the one to have preeminently produced and marketed opium in the Far East and entered narc wars with Chinese authorities. Now, heroic acts, along with changes in in opinions about opiates, came changes in opinions in opiate themselves. Morphine and codeine were isolated from the opium plant, and search for synthetic and semi-synthetic opiates was ignited. 1874, Charles Alder Wright prepared esters of morphine and codeine, acetylcholine, and mono and diacetylmorphine. His discovery went unnoticed. Tests were run on diacetylmorphine a few years later. Merck and Company synthesized etylmorphine, similar in structure to codeine, and marketed it as cough suppressant in 1898. The first semi-synthetic derivative of morphine. That was it. In 1897, a team of scientists at Bayer tested diacetylmorphine on rabbits and observed that it deepened and slowed respiration. They concluded it was another cough suppressant. They tested it on tuberculosis patients and saw it had suppressant effects. Henrik Dresser and colleagues at Bayer tested it on themselves and found it made them feel strong, heroisch in German, hence the name heroin for diacetylmorphine. Morphine chemical profile and biological activity is bound by the position of two hydroxy groups in positions 3 and 6. If one is modified, its narc activity abates, such as in codeine. If the two groups are modified, it becomes inactive, such as in T-bane. Both groups are modified by acetylation in heroin, hence its potency. It crosses to the brain faster and acts potently as it gets these very groups deacetylated in the brain by certain enzyme, turning the molecule into pure morphine. And that's how heroin has such a potent effect on the brain. 1898, heroin was for sale by Bayer as a cough suppressant with non-addictive properties. It was around the same time when the acetyl derivative analgesic antipyretic drug salicylic acid, or what we call aspirin, got to the pharmaceutical market. They both put them on the shelf side by side as very good at analgesia and to whatever they described them good for. It was also ushered into USA as a cough suppressant safer than codeine and morphine and less addictive. The fact it was only used for its therapeutic effect for acute respiratory disorders and orally ingested masked its real addictive effect or withdrawal, even when given to patients with chronic disorders who continue to take it for their sickness. So if they give them the drug, they didn't notice it could cause the issue because either it was for acute issues or for chronic issues, and in either case, it's either um, the patient is weaned off it before they get addicted, or even when they continue to be addicted, still it's for a disorder that they have. By the 20th century, it has been established that heroin is a dangerously addictive drug, and opinions radically changed. Junkies got their name from selling junks to cater for their heroin needs. Junkers were people in New York before the new junkies showed up. There were people that were called junkers because they made a living selling valuable discarded pieces of junks they collected, and people with addiction issues that couldn't cater for their addictive needs, they saw these people making money out of that and they started doing that, and hence the name junkies. People in England, they had similar names, and they had a name for them also. It's called rag and bones in UK. The Holy Grail. The semi-synthetic opiate continued to result in addiction, and the search for non-addictive ones continued throughout the 20th century. Now the issues is like full blown out, and they wanted to contain it. Procaine, an analog of cocaine, is an anesthetic with no euphoric or addictive effect. How to do the same with morphine? More than 200 analogs synthesized, and effects on animals and humans were measured. It was reported that inmates at the Federal Penitentiary at Lexington in Kentucky were subjects to such experiments where more reliable measuring techniques were used. 1950s, no successful results obtained. They were unable to separate the analgesic effects from the addictive effect. Opiates have their pharmacology profile. A few more compound molecules were produced. This long and extensive research helped clarify the chemistry of opiates at cellular level. The morphine compound molecule is a pentacyclic alkaloid, that is to say, 5 ring systems, 3 rings phenanthine, polycyclic aromatic hydrocarbon with 3 fused rings, bridged across 4, 5 by oxygen, and 9 and 13 positions are bridged by ethanamine chain. The molecule also contained asymmetric center, different from that, and different forms that can be mirror images of each other. From all this scientific jargon, we should understand that the molecule had a center that's asymmetric and mirror and reflective. And we'll understand more about it later. The opium poppy can only produce one of the mirror images. See, and they're not, you cannot superimpose them. Like they are this way, like the hands, and if you put your hand this way, it's no longer an image mirror for the other hand, but if it's this way. And they are also described as left and right, and you have to be have some advanced level of chemistry studies to understand that, or just basic can help you also. The opium puppy can only produce one of the mirror images, and we're talking about the structures, the chemical structures. When they studied, that's what they found. This type is the one that is pharmacologically significant, and the other is completely inactive and can be only lab synthesized. Modification of the chemical structure morphine and codeine has yielded molecules with similar properties, such as hydromorphone or strong semi-synthetic, still currently used post-operatively and sold under the name of dialodid. Yeah, I've seen this man as a student, and this is given to post-operative patients, and it got its name, as you see, lauded, so it got its name from laudanum. Vicodin, this also you know, and you know that from Dr. House, right? Series, that doctor that's addicted to Vicodin. So Vicodin is a combination of Tylenol and oxycodone. It's still addictive. It's non-opiate. It's both a non-opiate agent and an opiate agent. Etorphine is a synthetic opiate that is ultra-potent opiate with no clinical significance. This one you cannot give to patients preoperatively or postoperatively or for maintenance. This, you just use it to immobilize, for example, an animal that's really hyperexcited and you're afraid and it's in the zoo, such as a lion or something. And then you just put them out and immobilize them, or but it's a synthetic opiate that was derived from the morphine structure. A few questions emerge. Is the whole pentacyclic morphine structure needed to get a similar in effect morphine analog? Now, if we want to get something similar to morphine, should we keep the 5 structures? Should we just play with its center? So this can the same analog be synthetic, of course, and then removal of O2 results in structures called morphinone. They removed the oxygen from the structure, and the result was morphinons. Levorphanol, for example, and that's levorphanol is part of the left side image structure. So that's a structure, that's chemical structure, for example, is one of these of its enantiomer. Enantiomer is one side of the pair molecule that is non-superposable, as I explained, image of another. So there is levorphanol, the one that's on the left side, an enantiomer, and then there is dextrometorphan, the one that's on the right side. This one has little opiate activity. That is how it is used as a capsaicin. Now, breaking down the morphine molecule to simpler structures by removing, replacing some of its parts at the level of ring, at the level of ring C, results in potent opiate analgesics. Although they broke it down, and at certain level, they still got only strong and powerful analgesics with some hallucinogenic properties, such as cyclazocine and ethyl ketocyclazocine. Those were powerful and also had hallucinogenic properties. Simplifying the structure or removing a ring or two does not result in eliminating the opiate activity. That is what these experiments have shown. They could play around it, they could remove a ring or two, still they didn't know where was the strong activity happening. In 1926, IG Farben synthesized pethidine, antispasmodic, with some structural chemical affiliation to anticholinergic drugs. When tested on mice, They manifested what is called Stroud-Tail reaction, and that reaction is something that's specific to opiate reactions in animals. The drug has an opiate activity in pharmaceutical experiments that have been run before. Whenever they gave something that had opiate activity, the mice or the animal had that strap tail. Pyridine does not structurally resemble morphine except for 4-phenylpiperidine moiety, yet it has proven to be also highly addictive. It was and is sold under the name of Demerol. IG Farben synthesized many analogs of pyridine and came up with one simpler structure prior to World War II, also proved to be potent opiate. USA Pharma business works further on the compound and synthesized methadone. Propoxyphene, Davon, is another analog that is also used clinically. Janssen Pharmaceuticals synthesized structurally related molecules, fentanyl and alfentanyl, used in anesthesia, and they're used. They are part of the anesthetic cocktail that's used preoperatively on patients and intraoperatively. Many of the components of the chemical structure of morphine removed, replaced, or simplified, the outcome remained the same when it comes to addiction and related issues. These extensive studies helped us understand the relationship between opiates, structure, and function. Inhibiting morphine. Now, we have an issue and we want to try and see how we can stop it. Merck Institute at Rahway, New Jersey, replaced the nitrogen in morphine with N allele group. The result was nalorphine, which antagonizes the respiratory effect of morphine. Now we know that opiates are strong respiratory suppressants. So this product antagonizes that effect, nalorphine. Nalorphine itself has an analgesic effect, while it also manifested some of hallucinogenic effects together with dysphoria. It counteracts the respiratory effect of morphine. It has an analgesic effect, but it has some hallucinogenic effects. When methylcyclopropyl group was added to nitrogen instead, the result was naltrexone, an opiate antagonist. Methylcyclobutyl methane group, when added, the similar method yielded an equally potent opiate agonist. Other partial antagonists or agonists resulted by playing around with the backbone chemical structure of other opiate-like molecules. Levalorphan, with antagonist properties, resulted from adding an allele group to levorphanol. Buprenorphine is a methylcyclopropyl containing. It is a strong agonist. It is chemically related to atropine. And remember, atropine is the ultra-potent sedative. So, 1915, Julius Paul synthesized an N-allele group's derivative of codeine, antagonized the effects of morphine on respiration. This research was not taken into consideration until 3 years later, until a great deal has been understood about the molecular structure of morphine, its stereospecificity, and how its levorphanol is less chemically active than its dextromethorphan. Now, these extensive studies allowed for deeper understanding of molecules with partial agonists or full agonist antagonist effects could be possible, such as naloxone, and not can. That is now like a blessing uh, for people with who overdose. You give them that and to reverse the effects. The opiate receptor concept. Observational investigation initially led to the belief that opiates interacted with specific protein molecule receptors. Pharmacological research and accumulated scientific data prove that such specificity does indeed exist. Bioassays of smooth muscle responded as predicted when applying receptor agonist. When applied to receptor agonist, such bioassays were used in the first half of the century to identify neurotransmitters and drug interaction. Peristaltic movement, that contraction of the smooth muscle of guinea pig alien was inhibited, as observed by Trendelenburg when adding a small amount of morphine. The same did work for other animals. Oxford scientists demonstrated that the peristaltic decrease was caused by nerve cells within the preparation that expressed opiate receptors. The receptors, once activated, decreased the release of acetylcholine, resulting in observed decreased peristalsis. The bioassays did not produce any results when testing heroin. It remains inactive. Heroin produced results when tested on animals. Electrically stimulated concentrations of the mouse vas deferens suppressed contraction. Experimenters believe uh, that the opiate receptors was expressed on norepinephrine rather than acetylcholine. Dr. Snyder's breakthrough. The identity of biochemical receptors remained elusive until 1970s. They were believed to be scarce, and the technology to isolate and purify them was not available. 1960s, Earl Sutherland showed some of the results of activating biochemical activation such as cyclic uh, AMP, adenosine monophosphate. 1970s, Jean-Pierre Changeux and colleagues identified the nicotinic receptors for acetylcholine. They used snake toxins which interacted with nicotinic receptors and blocked them. They irradiated the toxins with radioactive iodine and applied it to electrical ear organ. The experiment helped purify and characterize nicotinic acetylcholine receptors. The method did not work as well with opiate receptors. It did not work at all until Saul Snyder works at Johns Hopkins Medical School laboratory, asked what radioactive drug to use in preparing an opiate receptor binding assay. Snyder and his colleagues used naloxone, opiate antagonist, which ended up to be a better choice than the opiate itself. It maintains its affinity for target receptors intact even when irradiated. They used tritium, the drug that incubated nerves and the drug and incubated nerve cells from the brain with it. That is how they were able to identify the receptors and their characteristics. Their binding was tight, saturable, and manifested the required pharmacological specificity. It was in 1973, other studies that were going on agreed with Snyder's and students' results. Snyder continued his research to identify other neurotransmitter receptors and interactions with drugs. Such studies influenced the field of pharmaceuticals. Now we come to the good stuff, enkephalin and endorphin. What one could understand from all this is that the identification of the receptor sites for drug means also the identification of receptor for neurotransmitter. Dr. Snyder identified many drug receptors and their respective neurotransmitter receptors. The question now is, what is the neurotransmitter that acts on opiate receptor sites? Dr. Snyder's studies found that ancient animals, vertebrates included, had opiate receptors. The question, how can we have such receptors unless we have an indigenous morphine-like receptor that is undiscovered? A fact which started the chase for this elusive neurotransmitter that is both a painkiller and a pleasure giver. In 1975, John Hughes and Lars Terenius laboratories observed that some extracts brain material manifested opiate-like behavior. They semi-purified the brain material and demonstrated that it exerted some activity on guinea pig ileum and mouse vas deferens. Their suspicion confirmed when the activity was blocked with naloxone, the opiate antagonist. That's it. That must be the opiate we are chasing. Contrary to what was expected, the indigenous opiate differs widely from chemical structures of known opiates. The active material is a small peptide that consists of a string of amino acids. It actually combines two different pentapeptides. Hughes and his friends called it enkephalin in an article they published in Nature. Experiments on animals further substantiated the idea of the indigenous opiates. The periaquatic gray matter in the brain produced analgesia. They were blocked by naloxone. Many questions were reignited, refueled, and can we now produce non-addictive opiate? Can we become addicted to our own? Enkephalin is an indigenous opiate with structure that is completely alien to that of the opiate produced by nature. Enkephalin must be non-addictive, right? Can we manufacture similar? The author believed those questions were naive. Many other indigenous opiates were then discovered that have to become collectively named endorphins. The largest concentration of such indigenous opiates was found in the pituitary gland. The endorphins are unstable and easily degradable by enzymatic activity. Analogs of endorphins that were produced by stabilizing those indigenous opiates resulted in addiction uses. They are non-addictive just because they are easily biodegradable. They show up when there is stress in the body, and then right away they are biodegraded and the effect is moved. When they try to make analogs of these, they try to semi-synthesize them or synthesize them. They removed a few parts of them or played around with the structure, and they got addictive substances. So the body is addicted to its own because is not addicted to its own opiate because it breaks them fast and gets rid of them. And how do we know? Probably we're constantly breaking down some and then resynthesizing them, and we don't even feel the need to go, can I have some enkephalin or endorphin because they're in your body? But still, when the stress is more than they can handle, you need to analgesia, external uh, chemical substances to try and restore that balance and help your body cope with the stress. Multiple opiate receptors. Pharmacology in the 20th century has many opiates and their derivatives. Bioassays have been used to identify the receptors. Dr. Snyder was the leader in the field of opiate pharmacology. Now we see how this name is repeated across this chapter, and hence the title for the chapter, Dr. Snyder Cabinet. So he was the leader in the field of opiate pharmacology. Hence, Costellitz preceded him, had helped develop opiate pharmacology, and used smooth muscle bioassays and coached his younger colleagues in the technique effect that led to the discovery of enkephalins. Costellitz and colleagues found out that peptides similar to enkephalin showed different strength in the mouse vas deferens and guinea pig ileum, which can mean they are different. Further bioassays experiments using irradiated enkephalins and naloxone, they found multiple opiate receptors such as delta opiate receptors, high affinity for enkephalins, and mu opiate receptors with high affinity for morphine, and morphine-like drug with kappa receptors have high affinity for dynorphin, and opiates with hallucinogenic properties. Catecholamines also have multiple receptors and influence a wide range of nerves distributed on a wide network. So this is an analogy between catecholamines and opiates. Opiates peptide neurotransmitters act in similar way, but without some cross-activity. There is some cross-activity. Catecholamines, they are specific. There can happen some cross-reactivity between these neuropeptides and receptors. Watson's opiate. Now let's go back to Robert Gordon Watson, the guy that traveled across the Americas and tasted some of those elixirs and concoctions in Central America, and joined those circles, healing circles, and initiated the drug to the mushroom psychedelic mushrooms to America and Europe, together with Alfred Hoffman. I have talked about that from previous chapters. Now, Robert Gordon Watson, anthropologist, ethnobotanist, and botanist, who chased the links between certain ancient potions such as the Vedic drink soma or the Eleusinian kykeon that powered the Eleusinian mysteries, and some still practice American rituals for religious benefits of certain mind-altering substances. He started a field called ethnobotany, which established links between certain plants and fungi in the genesis of religions. Hence, the term entheogen for such psychoactive plants and substances. He also had been involved in CIA secret projects such as MK Ultra. He was also definitely the one, according to many sources, the one that introduced psychedelic mushrooms to modern Europe and America. The book in this section takes us on one of his trips to Central America while attending one of the famous Central American curanderas healing nights with Alfred Hoffman. He discovered it's intense. He tasted a substance and discovers its short-lived psychoactive benefits. That's the emphasis should be on this one. Of a plant that can be brewed. They can brew the plant, smoke it, or chew it. The plant is called Lambadilla by the natives. It is known among botanists as Salva divinorum, the magic mint. The major psychoactive chemical in this plant is salvinorin. They they broke it down in labs and analyzed it, and they found a substance that's psychoactive, and they called it salvinorin A. Salvinorin A. It is not an alkaloid, but does not have the nitrogen base commonly found in psychoactive plants. Now, how does it differ from what we have seen? Salvinorin A is a diterpene and is structurally related to psychoactive elements of cannabis than to those of morphine. Yet it showed a very high affinity to kappa opiate receptors that are linked or to opiates or semi-opiates, semi-synthetic opiates with psychedelic properties. This excludes the specificity of those receptors. Now, opiate neurotransmission and the brain and the pain. How does morphine act the way it acts? You know how this book focuses on that. So the mu opiate, mu is like a Greek character. Sometimes it's used to mean the mean or micro. Here it's I'm reading it like that. Mu opiate receptors for morphine are widely expressed in the CNS, PNS, and ANS, in the central nervous system, peripheral nervous system, and autonomous nervous system. Morphine inhibits the acetylcholine neurotransmission released by cholinergic nerves, innervating the guinea pig smooth muscle of the guinea pig ileum bioassay. Now, the action of morphine or similar opiate is the same whether on smooth muscle or elsewhere. They inhibit the action of the nerves, they act on them. And that's what it is, that's how it acts. Now, let's see, if you have nociceptors that carry the noxious stimulus to the spine, and then gets to the thalamus, and then they get intercepted by interneurons that inhibit the pain reception or lowers the intensity of the pain. Now, morphine, when it acts on the brain, it affects those interneurons. It activates them even further and makes them more powerful, inhibiting the brain and prolonging that reaction. So then they go to the descending neuron that brings the nexus, and it makes you aware of the pain. For example, you burn your hand, you don't feel it, you feel it, but you think you felt it right away, you didn't. It went up the spine, it went to the thalamus, it stopped a little bit, and then you remove your hand, and then that's when you get the sensation of the pain. Morphine acts in a similar way. It inhibits the neurotransmitters, the neuron, from releasing the neurotransmitters that carry that sensation. And that's how that affects on the pain. Now, the chase to find substance like morphine and opiates with no addictive and outcome, but more therapeutic effect is still going on. I will try and be briefer in the next, talking about the next chapters, and we'll see if we can wrap them up all and make this just a few minutes talk. On the hope to do that, I'll leave you and then see you another time. Have happy Thanksgiving and happy Halloween, and enjoy the times you are living, and